All right, gang, let's try out another example of graphing a sinusoid. This time we have a cosine function. Specifically, y equals -3 cosine of x minus 2 over pi over 2 plus 2. So if we want to graph this, I always like to start out with my vertical changes and then deal with my horizontal changes. So our vertical changes come from A and come from K. So we get it from our leading coefficient and the constant we're adding to the outside. That value A tells us our amplitude. Our amplitude is always the absolute value of A. So in this case, the amplitude is the absolute value of -3, which is 3. Our K tells us our axis of the wave. So in this case, our axis of the wave is y equals 2. So what that means about our function is that we have y equals 2 is the middle of the curve, and we're going 3 units above to get our maximum, and 3 units below to get our minimum. So our maximum is 3 above 2, that's 5, and our minimum is 3 below 2, which is -1. So it goes between 5 and -1. That's what our curve's going to be. The lowest it's going to be is at -1, the highest it will be is at 5. So I'm going to start an axis, a graph for us. So we've got ourselves a y-axis here, and we're going between 5 and -1. So I'm not going to make it balanced. I'm actually going to be, since we're going to be mostly above the x-axis, I'm going to do my x-axis sort of low. And we want 5, -1, and 2. Those are the 3 values that are important, 5, -1, and 2. So a scale of 1 would be fine for that. 1, 2, 3, 4, 5, and then -1. So our graph is going to have, at 2, we're going to have our axis of the wave, and nothing is going to go above 5. We'll have a hard cap here and a hard cap down there at -1. So this is the framework of our graph. We're going to be between these two. Nothing's going to go above 5, nothing's going to go below -1, and everything's going to be oscillating around that y equals 2 line. So that's everything we need for the vertical. Now we just need to talk about the horizontal. So the vertical came from A and K. The horizontal comes from inside here. So in this, the first thing you want to do is you want to factor out what you're multiplying x by. In this case, it's x divided by 2. Dividing by 2 is the same as multiplying by 1/2. So if you factor out the 1/2, and it'd be 1/2 times pi, so it's x minus pi. A good thing to check on this is if you distributed that back through, would it produce that original expression? And in this case, yeah. 1/2 times x is the same as x over 2. 1/2 times pi is the same as pi over 2. So this one checks out. So this is your b because it's of the form b times x minus h. That's what the inside is. So that's b, and that tells us our period. Well, helps us tell our period. It's not our period, but our period is always 2 pi divided by b. So in this case, 2 pi divided by 1/2, dividing by a fraction is the same as multiplying by the reciprocal. Reciprocal of 1/2 is 2. So it's 4 pi. That's our period. So our period is 4 pi. So this function, it repeats itself every 4 pi units. And then there's the minus h. It's supposed to be minus h, and it is minus h. It's minus pi. So that means h equals pi. This tells us our phase shift. H is equal to pi, and it's positive pi, so that means pi in the positive direction horizontally, so pi to the right. So that's our phase shift. So everything, the whole curve, is just shifted pi units to the right. And then there's one more thing. It's a cosine function, and it's negative, so it would start at the minimum, go up, then back down. That will be one period of the cosine function with the axis of the wave here. And it hits the axis of the wave, it has the maximum, hits the axis of the wave, has the minimum. So it's broken up into 4 sections. It follows your pattern every fourth of a period. So a quarter of a period is an important value to know. That tells you how often you're going to hit one of these critical points, whether you're at the maximum, the axis, the minimum, or the axis again. So a quarter of a period is 1/4 of 4 pi, which is just pi. So I'm going to compile all the information that we have. We know our amplitude is 3. Our axis of the wave is at 2. Our maximums are 3 above 2, which is 5. Our minimums are 3 below 2, which is -1. We know our period is 2 pi over 1/2, which is 4 pi. Our quarter of a period is pi, and our phase shift is pi to the right. So that's what we can get from all the numbers. The only thing left to get is from the fact that it's a negative cosine. A positive cosine starts at the maximum. Our standard positive cosine at the y-axis is at the maximum, but this one's negative. So instead of starting at the maximum, it's going to be reflected, so it's going to start at the minimum. So positive cosine starts at the maximum, a negative cosine starts at the minimum, positive sine starts at the axis of the wave going up, and negative sine starts at the axis of the wave going down. So with all of this information, that's what we need to graph this. So if we go back to our graph, we had our y-axis all set with the scale. Now if we do the x-axis, we're going to look at these values, these 3. What our period is, what our quarter of a period is, and what our phase shift is. So we have pi, pi, and 4 pi. So we want we want our tick marks to be easy, where at our tick marks we can have pi, pi, or 4 pi. I'm just going to do a scale of pi. If I do a scale of pi, we'll check off that, we'll check off that, and then 4 tick marks will be 4 pi. So we've covered everything. If you did a scale of, say, pi over 2, that would work as well. But doing a scale of 1 or 2 or 3, not going to work out as nice because this is not an integer. So I'm going to do a scale of pi. So 1, 2, 3, 4, 5. So that's pi. So that's 4 pi. So from here to here, we're going to have one period. 1, 2, 3, 4, 5. So that's negative 4 pi, that's negative pi. All right. So we've got our scale on our x and y axes. Now, normally, if there was no phase shift, since it's a negative cosine, it would start at the minimum. So if there was no phase shift, we would be starting right there. And then every pi, we would go minimum axis, maximum axis, minimum axis, so on and so forth, and follow that pattern. But we have a phase shift, and it's pi to the right. So this point is shifted pi units to the right, which is right here. So we have minimum there, and then a quarter of a period later pi, we're at the axis. And then a quarter of a period later, we're at the maximum. A quarter of the period later, we're at the axis. A quarter of a period later, we're at the minimum. And then going backwards from minimum, quarter of a period before, we're at the axis. Quarter of a period before, oops, that's too far. Quarter of a period before, we're at the maximum. Then back at the axis, minimum, axis, maximum. So we have our points, and we can draw a curve between them. And that's our sinusoid. It's got an amplitude of 3. It's 3 above, 3 below the axis of the wave, which is at 2. It's got a period. It does complete one full cycle from 0 to 4 pi, or from pi to 5 pi, or from negative 3 pi to pi. Those are all one full period. It completes one full cycle. There we go. I hope that makes sense. Have fun.